Now we completed the presentations, including Dr. Sun's keynote. When I was preparing this session, I was told by Peter that I can entertain 2 rounds of questions and then interacting with the audience as well. So I prepared 2 sets of questions. 1 set of nice ones and 1 set of tough ones. But given the time, I have only 12 minutes, so I go only with the tough ones. 10 minutes. We can go over 10 minutes. Still, my tough ones will require more than 10 minutes. So I would start with Jaquelin. You have talked about experience, learned a lot about U.S. Energy system. I think that the America is very privileged in having natural gas, flexible, cheap, low carbon, relatively. Very fortunate to have natural gas, so that can meet the peak load, the base load, the flexible, can interact with the wind, the solar. So what would be your advice for a country like we in Asia, with not that privileged? We don't have cheap natural gas. How do we go for a higher level of renewable in a context that where a lot of coal, we still use fossil fuels, and solar is still expensive? What's the best way to go?
Thank you. So I do a lot of work with India, and that is a unique system in that it is really large, but it is common in the sense that it's coal-dominated. And one of the, we have just recently been working with the system operator on planning for their 175 gigawatt renewable energy target, which, if our modeling is correct, would give us penetration levels of about 22% as meeting annual demand with the wind and solar, just with wind and solar. This is able to be done with the coal-dominated system. They don't have, they have very little natural gas. Natural gas does not play much role in flexibility. Hydro does, but coal itself is also. In addition to coal, I would say there are sort of 2 big, there's, I guess maybe the biggest conclusion of that is that we can integrate 160 gigawatts of wind and solar just as is with the coal-dominated system. But we did find 2 other things that are really significant in driving renewable energy integration. One is having better cooperation in scheduling and dispatch. So for example, right now in India, the decisions about what electricity is going to be needed the next day is made at the state level, state to state. And so you can get a lot of efficiency savings by having better information and market exchange between the states. The other big driver to helping renewable energy integration is the ability of the coal plants to turn down lower, so that during the day when they have 100 gigawatts of solar on the system and the generation is really high, if they can turn down lower, that helps reduce the renewable energy curtailment. So that is much more critical in the India system than something like ramp rates or how fast does the coal change, because the system is so big. But when we've worked, for example, with the Philippines, that too is a coal-dominated, thermal-dominated system. And there, the ramping issue is a bigger concern, and reserves, having enough capacity to provide reserves is critical, and that's where wind and solar can really actually help the system. So it does depend on the size of the system in terms of what are the challenges, and or I should say what are the solutions, but coal can serve as a balancing asset.
Thank you, Jaquelin, for that. And that leads me to a next question to Niels. Germany, I think Germany also very fortunate. You have a neighbor that has a lot of nuclear. So Germany without France would still run 50% of renewable? That's one question. And second question, can Germany, to what extent the Germany coal is operated flexibly to meet the growing share of renewable?
Sorry, the first question?
So the question is about Germany being center of Europe. You have interconnection. with France, and France is actually supplying. France is exporter of power to Germany, and Germany is exporter of power to everyone else except France, meaning that
France, I must say, is a special case because in this January, France had major issues with their nuclear power plants, and they were highly dependent on imports from Germany. They had, if it would have been cold this January, I mean really cold, like minus 10 degrees in France, they would have load curtailment because they have had a lack of power this year. So indeed, but of course they are exporting quite a lot. There are 3 major exporters in Europe. One is Scandinavia with lots of hydro. It's Germany with lots of renewables and lignite, I must say, which is with a given carbon price still cheap, and France with nuclear. Regarding the integration of renewables, it is indeed true that interconnection helps a lot because we can use a portfolio effect, we can export power, but still, I think it would also be possible to include lots of renewables without having these interconnection. You just have to design the market in a right way. And regarding the coal power plants, we've seen very flexible operation of the coal power plants. We've even seen, once we had some price incentives with very low prices, we've even seen that the nuclear power plants, who were normally just operating baseload, started to react to prices and go out of, not out of the market, but at least ramp down in times of low prices.
Thank you. Thank you very much. Next question, I go to Bartosz about new technologies. Actually, I attended last Energy Congress. I was having a conversation with some expert, and they're saying, you know, all these technologies, we engineers, believe me, we engineers can do everything. The problem is some economists don't allow us. So how about your technologies? You're very upbeat about the future of technology. How about the economics? How about the cost? Do you believe that that will be part of equation when you give this optimistic picture of future?
Well, I'm not sure if it will be optimistic, but I will try to answer my best. As a 25-year subject matter expert in energy and also person who lived in Philippines and ran innovation business for Meralco, this is the fundamental problem. Our entire discussion is incorrectly set because the entire conversation is about technology rather than the fact that electricity is a commodity. And we cannot design technology, we cannot design the system if we don't understand the value of electricity to every society. For example, when living in the Philippines working for Meralco, 60% of our population was underprivileged economically, which means they were making 400 pesos a month. So the question is, if you have a 400 pesos a month and the cost of electricity is on average 15 to 25% value of the money you're making, how do you innovate? It's not a technology discussion. The question is, how do you create a value? Therefore, do you have technology available that can be affordable per share wallet of the customer? In Philippines, the share wallet of services is 5%, which means 20 pesos per family of 5 or low social economic. Can they afford to pay that much for electricity? That means you have to find a technology that is financially and performance viable for the customer. Listen, guys, it amazes me that you know, we spend so much time talking technologies where technology is truly not an issue. But the question is, how do you really match the technology financially for the share of wallet of availability for the customer to pay? Second of all, according to Bloomberg, there's over 2,000 projects globally in the space of smart grid, IoT, smart cities. 70% of those projects are in the R&D phase, and 50% of those projects will be scaled. You cannot talk economics without designing for scale, and we are constantly playing with pilots that are never scaled. Third element, the average pilot project in the energy space lasts 5 years. By the time pilot project is done, there is a huge probability that technologies we're using are already obsolete because the lifetime of the return on investment is, you know, 5, 7, it's not anymore 20, 30 years when you had a mechanical transformer sitting out there. So the whole concept, deploying historical approaches to innovate the future, and we are then wondering why we cannot have financial scalability of the outcome. And again, utilities in the past were run by engineers, and that's wrong. Companies were run by technologists, that's wrong. You need to have actually someone who understands how to scale the business. And again, I'm speaking as an engineer, so I'm speaking against myself. I hope you understand this. So again, historical approaches have to change, and we have to look at the innovation completely differently. Therefore, the share of wallet, the ability how you quickly scale to market, how you put the financials, flexibility of financing. The whole regulation model is broken. You invest on CapEx, on the technology that evolves within 18 to 24 months, and the regulation period is 5 years for most of the utilities. It's a constantly a losing battle if you look at that from that perspective. So I will pause it now.
Thank you. Thank you, Bartosz. Let me move on with a question to Mr. Kumar. Mr. Kumar, you talk about the new business models for Asian utilities. I was recently in Bangladesh, and I met some, not utilities, but off-grid people. And their greatest worry, actually, there are two worries. And the one worry was, someone like we give grant to distort market, but that's not subject today. But the other worry is the grid people would come to our off-grid areas to extend their grid, then our business model is lost. So what do your view of, because in Asia there's so much people without access and off-grid offer solution. And grid people, utilities, how in their business model, how will take care of this part of the world without access to electricity? Do you believe eventually we should extend the grid to entire country to make sure that 100% you have 24 hours, and that's part of a new business model? Or we leave a space to off-grid people and for them to innovate, to have their technologies? So what's your view on that?
Yeah, thank you so much. Yeah, that's a very, very valid question, I think, and not just Bangladesh, even in India and other neighboring developing countries, we are facing this issue where access is a problem, and in some of the states in India, for instance, the generation supply is not an issue, the availability of power is not an issue, but the last mile connectivity or the grid is an issue. So extending the grid is obviously a natural solution. If you can build a grid which caters to all the consumers, even in remote areas or wherever, that's obviously the best solution possible. But historically, we've seen that that's not been possible. And so various models of off-grid solutions have emerged. And we've also seen that some of the renewable technologies integrated with off-grid solutions offer a very, very viable solution to the off-grid supply. So I think, both these models will have to work in tandem for some time. The utilities are already facing challenge in terms of finances to, actually adapt to the new ways of working, the innovations that they have to do, invest in the renewable sources. At the same time, they also have to extend the grid, which is taking its own time. So till that time, I think off-grid solutions have to be part of the solution, coupled with various sources of distributed generation of renewable sources. So I think that is, both of them are going to work together in these countries, I would feel.
Thank you, Mr. Kumar. Now let me move to Richard on hydropower. I think hydropower people are nice ones because you never ask. I'm not sure you never ask, but you don't usually ask for subsidies. Nevertheless, hydro, as I mentioned yesterday in my opening remarks in your session, 25 years or 30 years ago, when we talk about renewable energy, is basically hydro. Today, in our forum here, when we talk about renewable energy, first thing comes to the mind, of course, solar and wind. Hydro comes later. But hydro has a great place in the energy system. So what do you need, actually? Why hydro has come to, from the first level, first class to the third place? Not in actual share. I'm sure actual share is still very high in renewable. But in terms of policy, in terms of people's perception, in terms of way of pushing for more renewable with hydro, what do you need from government, from ADB, so that we can bring hydro back to its place. Sometimes I'm saying make hydro great again. So what's your advice?
Okay, I think hydropower is great. Otherwise, I wouldn't have spent 30 years of working in it. I guess I'd have to say that. But I was in the Paris meetings for the COP21 where the head of Microsoft said, if only we could have a renewable that was dispatchable. So there's obviously, coming from Microsoft in particular, that's a real communications problem that we have here. When a communications company communicates that they don't understand the difference in terms of level of service from the various renewable technologies. And, you know, we had a quick chat before we had started this panel discussion on let's not mention balancing, dispatchability, etc., ancillary services in great detail, because we lose people. And we have a real challenge in communicating. And I think the hydropower sector in particular is not being good at communicating what it can deliver. But how do we commercialize also those services? And that's a real problem, because you can build those services into a hydropower project and you can also build them out. And a lot of that comes down to something we haven't discussed on this panel. Who's doing the building? What's the motivation behind that? How are we introducing policies and markets that are going to end up with the right projects in the right place from a systems point of view? It's all very well talking about 3/4 of the world's renewable electricity comes from hydropower. It's much, much more important, in my opinion, talking about how that's going to facilitate the greater progress of the other renewables. But how do we incentivize that in the projects that we're building? If we look at China, has developed 300 gigawatts this century of new hydropower, 300 gigawatts, a phenomenal amount of development. And yet it is still now planning to build 23 pump storage projects because it needs additional storage. That tells something about the portfolio that exists in China has not been built for the future. It was being built for the present day challenges of bringing firm capacity, base load into the market where electricity was very much desperately needed to drive the economy. But the future power is going to be one that's very flexible, dispatchable, providing the ancillary services to support the other renewables.
Thank you, Richard. Now let me conclude this session, question-answer session with Dr. Sun with your presentation on the outlook of the energy in future. I brought to simplify what I understanding, by 2050, around 2050, we'll have 50-50. 50 fossil fuels, 50 renewable. It's easy to remember. 2050, you have 50 fossil fuels, 50% of renewable energy. But that's global. My question to Dr. Sun, to you is, how about Asia and Pacific? Whether we're on the higher side or lower side of a renewable, given Asia's challenges, as you mentioned. So question is, globally 50-50, but how about Asia? We are on the high side or lower side for renewable energy?
Okay, thank you for this one. And I feel that the Asia in the future is for the economic and also for the energy, the transition and the consumption is a major driving force. The major, the incredible part is from Asia. So by this figure, I feel that Asia also mainly two parts. And for some of the advanced countries like Japan and others, I feel that may be higher in the renewables. And just now, a gentleman mentioned that Denmark, one day, no any of the fossil fuel, only for the wind. Probably that day, wind is very strong. And then whole country use energy from the wind power. Yeah, so this is very special. And also North Europe countries. In Asia, like Japan, like this, and also the countries with enough of the finance, high technologies, and also for the support of the government. So by this, I think be higher. But some of the countries like the China, India, yeah, this is the bigger population and also bigger consumption of the coal. Yeah. Now China, India coal consumption around 61, 203, something like 6203, something like this. Yeah. So after a few years, even 20 years efforts, I still feel that coal is still an important part of this. So by this one, I personally feel in Asia by that time, most probably is only a kind of personal view. Most probably is also 50-50, yeah, because the part, and because the Asian country also develop fast, and the government. So far, we can see that the governments of Asia all have the general consensus. Yeah, the trend for the future of the energy should be green. Yeah, so that's the general personal comment.
Okay, thank you, Dr. Sun. I would like to, with the remaining 5-10 minutes, I would like to have a quick round of questions, answers from the audience. Anyone has a question? Got a question? Yeah, over there. Yes, please.
Oh, thank you for the presentations you have here today, this morning. With the defined goals you presented this morning, I think the climate goals and to stay below 2 degrees or even below 1.5 degrees increase, I think are not achievable. If we leave coal-fired plants in the equation of the plant build-out, especially in the long term, I think there are more drastic changes in scaling down coal-fired plants and shifting more decisively towards renewables, which I think is possible, and that was stated also in some presentations. So how do you see that?
Any reaction? Yeah. Bartosz, please.
If we close coal power plants, most of the coal power plants today, we're going to end up with about $1 trillion in stranded asset. Who pays for stranded asset? We all, through the regulatory rate case. So actually, we are looking at the technologies that can eliminate coal as a fuel, keep the coal power plants working, and use a special biomass that for every ton replace of coal, we can reduce 80% of CO2 emissions. So the dilemma is really how to leverage existing technologies, extend their lifetime without having a lot of cost at the hand financially, because again, at the end of the day, we all pay for that. So this is a challenge where we are trying to also address through the very disruptive technologies.
Thank you. One more question over there.
But if you're still building out and putting in more coal-fired plant, more coal assets into the equation, I think you accelerate the problem with stranded assets.
That's why this is for the existing assets. 50% of coal power plants globally has 50% lifetime still remaining on the books. So I'm not talking about building new, I'm talking how do you address the problem at hand right now.
Okay, question? No.
Good morning, Hans Frederick, Director General of the International Bamboo and Rattan Organization. And you can imagine what my question is. What is the future of biofuels in Asia? You've talked about wind, you've talked about solar, you talked about hydro. What about bioenergy?
Biofuels? You have an expert on biofuels? Huh? Yeah, please. Richard.
From one of our partners, the World Bioenergy Association, I feel obliged to make a contribution. I see it as a really essential, has an important role both in the heat and the generation markets, and of course in the transport sector as well. It's a matter about sustainability. It's a matter about communications, and I think there's been some real misinformation around consequences of raising the proportion of energy delivered through the bioenergy route. And so much of this comes down to how can we communicate the strengths and the weaknesses in a balanced way, a credible way. How can we make sure that there is a full appreciation that there are major opportunities there and not threats? We talked about the word crisis in Chinese, talking about the fact that I think people that see bioenergy as change have to look at both sides of the equation. The stakeholders that are going to lose something out of it and the stakeholders that are going to gain out of that. And if we understand the perspectives of both sides of the equation, I think the bioenergy technology and all of its breadth has a great future, an important future.
Okay, thank you, Richard, for taking care of biofuels from Hydropower Association. Any more questions? I would like actually to summarize and conclude this session. We're already a bit over time. As I understand from the panel, our 6 panelists, and I want to say that after this session, more than ever, I believe that the future of energy system will be a mixture of different fuels, but we want to see this mixture low carbon. But renewable energy will be important part of this energy mix to energy demand. But talking about renewable, we should talk about renewable energy mix as well, in which we have hydropower, we have solar, we have wind, we have biofuels, we have geothermal, maybe ocean power, and different formats. We should from now on to talk about renewable energy mix to meet our growing demand. But for that, I think a lot of policy issues will be required, policy support will be required. We sometimes talk about intermittency technically of wind and power in generation, but I think in order for us to deliver sustainable renewable energy mix, we need to avoid the policy intermittency. We need to have a stable policy, stable regulatory framework to support us moving forward to 2050. I hope that by 2050, we'll be correct in our projection that renewable energy will take a major share of the energy system by that time. We'll come back, Bartosz, you'll show, and thank you very much. We would like to invite the audience to join me to thank all our panelists for their work, for their sharing their thoughts. Thank you very much. Please stay on stage as Peter Dupont makes some housekeeping announcement.
No, I just wanted to say I learned 2 new words, policy intermittency. I got a PhD in public policy. I'd never heard that term. That's great. Thank you. And photovoltaics. Thank you, Richard. I hadn't heard that one. Just some house announcements, and the 4th one is extremely important. The first one is the next session, don't worry, don't sweat, it'll be 11:15 because they have to put the walls up and reset the rooms. Don't leave your bags, take your bags with you because they may be rearranging the room. Second, lunch will be upstairs, up the spiral staircase in the executive dining room after the next session. Third is this hall will be filled with 25 dynamic entrepreneurs from 4 to 5:30 p.m. today for the knowledge networking. It'll be a fantastic event. I wanted to advertise that. The 4th, this is really important. Don't stay out drinking too late tonight because tomorrow morning we're starting early. So, and I'll tell you why we're starting early, but it's at 8:20. I know that's a little bit rough, but when you're having your nightcap, just keep that in mind. 8:20 tomorrow. You should try to get here a little bit early because we don't want to have a stage with no audience. Okay. And the reason we have an eminent speaker tomorrow, and this is a new aspect of ASA from 10 to 11:15 a.m. Hiroshi Komiyama, who's with the Mitsubishi Resource Institute, is going to give a talk called Beyond the Limits to Growth. That will be in the multifunction hall in the new wing. So that's a special thing we're doing this year at ASA from 10 to 11:15 a.m. Tomorrow. And finally, the closing plenary will be in this room tomorrow. So we'll see you all again from 2:30 to 4:30. Thank you.